Let us consider the same coin that we used in the video about geometric distribution, the one which had 80% probability of showing heads. But here we are going to do a different experiment. We are going to toss the coin 5 times and count the number of successes and failures. Heads being success and tails being failure. So we can use the words heads and success interchangeably. Here again, we will consider a variable s which is defined as the number of successes. Here the range of s, that is the possible values of s, are 0, 1, 2, 3, 4 and 5. S equal to 0 means that in a given experiment there were no heads. All 5 tosses yielded tails. S equal to 1 means that in a given experiment one of the tosses gave heads and the remaining were tails. Let us now develop the probability distribution for the variable s. For that, we will answer the question, what is the probability of getting 3 successes, that is heads, in 5 coin tosses? Consider one of the possible results where we get 3 successes in 5 coin tosses, such as TH, THH. The probability of getting this result is probability of heads raised to the power of 3 times the probability of tails raised to the power of 2. However, we have considered only one of the possible ways of getting 3 successes. There are several other results where there will be 3 successes. For example, TTHHH or HHHTT or HTHTH, etc. And we have to account for all these outcomes. So we have to multiply the product of the probabilities of heads and tails raised to their respective powers of 3 and 2 with the number of ways to get 3 successes in 5 coin tosses. Let us find that. There are 3 successes and 2 failures. And there are 5 available places or positions, and the 3 successes can occupy any 3 out of 5 places. The number of ways that 3 successes can occupy 5 available spaces is 5 choose 3. That is 5 factorial divided by 5 minus 3 factorial times 3 factorial. So the final calculation to get the probability of getting 3 successes in 5 tosses is 5 choose 3 times probability of heads raised to the power of 3 times probability of tails raised to the power of 2. This is equal to 0.2048. Note that in this example also, each coin toss is a Bernoulli trial. We can now generalize the calculation. If there are n trials, then the probability of getting k successes, where k can be any integer from 0 to n, is n choose k times probability of success raised to the power of k times probability of failure raised to the power of n minus k. What we have now is the general expression for binomial probability function.